All right, we're back for a Sunday morning edition of Advent of Code. Been off for a couple days, which was nice, but let's get back to it. I've been seeing things on Twitter and on Reddit and stuff about later problems, and I'm excited to get to them. So, last time we had invested some time, maybe well, maybe not, I don't know, but it's always nice to do things the right way every once in a while, even if we could probably have shortcutted our way through it. We had to solve this problem, number 7, where basically there are a bunch of Unix-like commands where we're drilling into a file system. We need to parse the commands, turn it into a directory, and then read off the sizes subject to some constraint, essentially. And so last time, we did a bunch of good stuff around the parsing, which was non-trivial. And again, you can kind of hard code your way there, but I think I have a feeling this sort of thing is going to come up again. So it's always nice to kind of start to build out a parser, and maybe this becomes kind of a parsing framework over time, potentially, where we had this parser that has a string that it's parsing, has a pointer to where it's parsed to, and it knows how to parse out particularly commands right now, but we might generalize this later for some of the other problems, which would be cool. So we implemented the parser last time. All of our tests were passing, I'm pretty sure. No, I mean, not the two that actually test the problem being solved, but everything else passed, which is great. So the last thing we need to do is to build the tree from the parser. So, how's that going to work? Well, the file tree right now is represented as a tree of nodes, we'll say, but basically a node can either be a directory or a file. So a file is going to function like the leaf of the tree, whereas a directory has within it a vector of file tree nodes. And so all we need to do is parse. It's not really a parser, really. It's more like a lexer, but get the tokens, get the command stream from the input string, and then pipe that into our nodes, and our nodes will basically be responsible for saying, hey, am I up to a leaf node? If so, then cool, I'm a leaf node, and I exit the function. Otherwise, if I'm a directory node, then I will recursively pass the command stream down to the next nodes in the tree. So let's go ahead and implement that. And do we want to write a test for it? Probably. Okay, let's go ahead and write a test for it. Do we already have a test for it? Parser parses. I don't think I did that already. Parser peaks, command stream, file tree constructs. This seems like a reasonable place to put it. Okay. I should switch the view back. Okay. Cool. Test file tree constructs from command stream. And let's go grab a command stream from one of our other tests. Let's see here. Do we have a command stream? Not really. Okay, let's just take one of our, let's take a command stream that we've already tested. So let's take this one. And there's a little bit of a weird thing here in that this one ends with a CD, but I think that's a case we should be able to handle. So it's probably good. Okay, let input, let stream, and then we'll say let tree be file tree node, from command stream. It will pass by ownership because we're going to need to, in fact, it'll pass by mutable ownership, or there's no such thing. It'll pass by ownership. And then we just want to assert that the tree looks a certain way. So how should it look? It should have I'm realizing this isn't quite going to work. We need a few more lines than this, I think. Because we can't just have a directory that doesn't have leaf nodes. CDA, ls. That's maybe not really what I want. CDA, ls. Oh, you know what else? We haven't handled cd ... yet. Maybe we don't need to, actually. In the Lexer will just, it'll handle it automatically because it'll just say cd ... and then we'll handle that as a return, essentially. I guess in principle, this thing could, like, CD back into some, like, earlier. It doesn't seem like that's what it's doing, but we're kind of making an assumption that it's not, it doesn't, like, get partway through the file tree and then say CD/, in which case that would be a very different looking tree. But I guess we can just panic on that for now and see if it ever happens. Okay, let's take this, though. And what to do here? We can say this .toString, comma, and okay. And now from command stream doesn't exist. That's fine. And now we want to say what? We want to say assert equals tree dot size, was it? Length? Count? It doesn't know what type tree is. What did I call that? Okay, it is just length. Length and depth. Okay. So tree.length should be, well, it should have the root folder, it should have a directory A, it should have B, C, a directory D, and I within A. So it should be 6, its depth should be 3. It's always an interesting question when you're writing tests like this. Like, this is always my instinct, is to write easy top-level checks first. But it's kind of interesting because, like, if one of these fails, it actually hides a lot of information. Like, it's not going to throw a very useful error message. It's going to say, oh, the length of the tree is 0. Which I guess that one's useful, but if the length of the tree is 3, then I'm going to have to go digging around in the debugger to find out what's going on with the tree, rather than if I, like, asserted particular things, you know, what its first element is and so on. But I don't know. I go back and forth. Okay, and then let's assert equal tree dot I'm gonna create the function here because it makes it a lot nicer from the point of view of from command. Here, file tree node. Do I not have a new function for file tree node? Oh, I don't need one because it's an enum. Okay. From command stream, stream, and we want it to take it by ownership and return a file tree node, which is just a self. And then let's just make this unimplemented for the moment. And let's go back to our test. So now we should be able to say what tree. Oh, we can sum sizes. That's like a nice way. So let's assert that the tree sum sizes is 1484514 plus 8504156 plus 584. Do that right? 148 8504167 4156 584. Okay, and then assert equal tree let's see here. I guess I can match my way all the way into the tree. I can just write the tree down myself. It's the easiest way to do this. It's always so clunky. This is where Copilot is actually really useful, because it will like boilerplate a lot of this stuff for you in a really nice way. But I feel like Copilot is kind of cheating. I think this is enough for now. I don't want to spend too much longer on this problem. I feel like I've already gone a little overboard. Okay, so how to do this? Well, we are going to match on. Let's see here. Let next command be stream.pop match next command, and this will either be this can be a none. So under what circumstance would this be a none? So if we had a whole bunch of files in the last directory and then we got to a leaf node at the end, we wouldn't know at that point that we were done consuming files. So this should just return this can't just return. So we have to have handled that case already. Let's just think about a couple of cases here, because I wonder command is cd, then that means we're changing directory. We need to call from function on the directory. If command is ls, then then it's going to list off all of the items. So we need to already be in a directory node at that point. So then create directory with contents. If command, I guess if the command is cd dot dot, then just return, because it's the end of a list of files, and we need to go back into the parent. So I guess we're going to be popping multiple commands in general. But we should always expect the command stream to have more elements at the beginning of the function, and we should panic if it doesn't, I think. And yeah, there should be a bunch of types of commands that can't really ever happen here. So let's see here. So we should have so if next command is a none, then we can just panic. From command stream called on empty stream. We should just never do that. And I guess we can write this a little bit more eloquently as next command dot pop dot expect, and now it can't be a none. And so then if next command is command cd of dot dot in particular, then we want to return, but it really should never be that here. In fact, the only things that should be here are is ls or cd empty, I think. cd of slash, then and in fact it's the same either way. Is it? No, it's not. It's not. So if it's cd slash, if it's cd dot dot, if it's cd dot dot, we want to return. If it's cd slash, we want to just parse through it and get to the next ls. So the whole point of this function is going to be make sure we're not hitting anything we don't expect, get to the ls that matters for us constructing everything, and then do the constructions. And recurse as needed. So let's say trying to think of the nicest way to, I guess we can say, all right, let's say match command still, And if it's this, then we just return self from command stream of stream now that it's popped off, and we're fine with that. And if it's ls, then put some contents. That's where most of the magic is going to happen. And if it's anything else, then I think we panic. Unless, yeah, because we're going to be able to get to the ls from command stream called on a non-ls command. We'll say non-initial non-ls command. Panicking. Okay. Cool. This has to be a two-string. Doesn't. What's wrong with this? Expected string found string. Okay, so two-string. Variant has one field. This pattern has two fields. Tuple variant has one field. Pattern looks like it has one field to me. Oh, I'm not. Am I not allowed to say this? I might not be allowed to say this. I might have to say S. And then match S. Then this. And otherwise, panic from command stream. Called on CD, but not at the root. And it still doesn't like this. Expected reference to a string. I guess it can't coerce. I don't think this works either, though. Whoops. And stream.pop Okay. All right. So now we just need to handle the recursive case. And we will do this by saying for f in contents match f command result file. So if it's a file, then it has a name and size. Then we want to return file tree node, file name, size. No, that's not what we want to do. We want to file contents vec new, and we want to file contents dot push file tree node. Right, so basically the idea is, this out of my way. Okay, the idea is to we're parsing through a bunch of files, we have its contents, and for each command result we want to push something onto file contents, which will either be a file itself or it will be a folder. Command result directory name. Is that it? I think. And then here's where we'll say let directory node be from command stream. So this is where we recurse, and then we say file contents push directory node, and then once we're done looping through the contents, we say return file self directory oh, where do we get the name from here? Ooh, that's annoying. The name comes from the previous, from CDing into it. Okay. Let's just say file name, and we'll fill that in. And then this is file contents. Okay, and so now everything is looking okay here, except that we don't actually know what the file name is, because the file name comes from a previous command. Also, we maybe don't want to return yet. Yeah, okay, so I think we need an internal version of this function, because I'm noticing a couple things. One is that we have no way to get the stream out of here. And the second is that we have no way to get the file name that we are currently in. So, we will follow a relatively common pattern in which we have an internal version of this same function from command stream recursive, which takes, instead of just a command stream, we'll still take the command stream. Needs to be mute. But it will also say file name. And it will return both a self and a command stream. And all of this will be in there. I believe. And this guy will be, so the name of the file will be /, that's fine. This guy will be led to return stream b, or this can just be empty. Stream and file name, which we won't know. But we should probably just parse the initial command because we know that it's going to be cd/. So let's go ahead and pop that off. And we'll just say the next command is equal to command cd/, and then we can go /, and I don't know why this is a string. It doesn't need to be. It can be a string slice. Okay. Cool. And now we never want to see, do we ever want to see CD in here? I don't think so. So we can get rid of this, I believe. Okay. And we need to do something with, so for files, file contents not push. So we actually don't want to return here though, because we need to handle CD. We need to handle the other commands that might come after ls, namely cd, the only other command we know about. So eventually here we will return, how did I order this? Put this off first. File name. No, stream. But first we need to kind of peek at the next command. But we don't want to. Do we want? Yeah, I guess we do want to pop the next command also. So match stream pop. So if it's none, then are we happy? Yeah, if it's none, I think we just return. So we can do nothing. If it's some command cd file name. Wait. We already have file name. This just needs to be toString. And if this is some CD, then we need to handle that. So if it's ... let's just do this as a string slice. And if it's ... then we can do nothing because we're just going to return. If it's anything else, then we need to then we're expecting an ls, and this is what gives us the next file name. When we recurse. So this needs to be from command string recursive, and the way that it's going to know the next file name is that we're already going to have looked at a CD. Maybe. So we're expecting an ls. So maybe we just need to expect a CD first. Maybe I'm doing this in the inverse order of how I should. So we expect a CD first. That gets us the child. That gets us to a place where we expect an ls, and then we know the child directory name. I think that's right. So this actually is command cd. But then what if it's a ... That's what I don't love. I'd rather do this in the other order. WGAFA says hello. Hey WGAFA, how you doing? Working on some Advent of Code. Day 7. I'm a little behind. Just trying to get the recursion right. Because the trouble is also that we can have like CD, CD, CD. So at the end, we can expect, so after LSing, we either expect to pop back out, in which case we can just return. We expect to go a layer deeper, in which case we should add more. So maybe this does work. Maybe this does work. So this is just, so this one is based on the file name we got. When it was called, and then this one is going to be child folder name, and we've already popped the CD, and so now we can say the only thing is this can happen in a loop also. Can we CD multiple times in a row? Probably. Maybe it depends. Again, the question doesn't really specify whether you're going to go through the directories in an intelligent way, but I kind of think it goes through the directories in an intelligent way, in which case it's going to ls at every step. So let's assume that we don't, and we can panic if we do. WGAF says, yeah, I got stuck on day 8, part 2. Something's wrong with your code, but you don't know what. So you might just skip part 2 and keep going for the rest. Yeah, that's fair. That happens. I'm not at day 8 yet, but I'm hoping to get there today. We'll see. Day 7, I think I've gone a little overboard on the parsing. If I'm being honest, I think I probably could have done this I could have shortcutted this, but you know, it's fun to try to do it right. What language are you using, WGAFA? Child folder name. So here we can say those are a bunch of nodes. File contents push, or rather, let child node this needs to be directory node stream. Self command stream recursive stream file name. doing it in Haskell. Oh, cool. I have not. Haskell's functional, right? I have not ever used it before, although I've dabbled in Elm, which is obviously at a very different level of abstraction, but is pretty cool. Okay. Yeah, it's functional. Yeah, that's what I thought. This is not going to work for multiple reasons, not the least because I'm shadowing my own stream variable here. I feel like I have 2 recursive cases, which isn't what I want. Let's look at the problem input. Okay, yeah, we absolutely can CD multiple times. We absolutely can CD multiple times. Always out, though. Let's look at the actual input. Oh, right, and we can also have... Oh, no, that's LS. Okay. Yeah, so down at the end here, I expect a whole bunch of CDing to happen. Yeah. So CD should kind of be the trigger. So LS always follows a CD. Oh, nope, that's not true. You can have CD dot dot. But you CD into anything, it should always be LS, and then we would just want to pop out whenever we see CD dot dot. CD dot dot is like, should be the end of the recursion. Of a level, no matter what. So I basically want to expect a CD dot dot or the end of the file at the end of the recursion. And then I want to expect a CD into something. And once I CD into it and it's not a CD dot dot, then I can do my LSing. I think that's a little closer to what we want here. So if we get a CD, then we get the directory name. If the directory name is is dot dot, then we've done something horribly wrong. Expected a proper CD, but got dot dot. Otherwise, we expect an LS. So let ls command, bstream.pop, match ls command, and then it's going to be something like this. Where's the end of my thing? Something like this, although not this. So if it's a file, we push it on. If it's a directory, then we get the file name from folder name. And then we should just be looking for a cd dot dot or more CDs. So I've totally screwed up my parentheses here. No, I thought. So if we get anything that isn't an ls, or the end of the function, I guess. So this has to be okay. ls or some. Should be some ls. And then if none, no, we always expect ls after cd. And then if anything else, we say expected ls, but got. Okay. And so then the only other thing we have to handle is that once we ls and do that whole thing, we then need to pop the cd dot that comes afterwards. Now, we might not have a cd dot. We might still have to dig one deeper. But in fact, this already would have hit. This recursion already would have hit any cd dot dots. So and also we can't do this way. Recursion results be that, and then we say stream equals recursion results dot 0, and no, 1 and let directory node be recursion results dot 0. Okay, so this is compiling actually, and then the only problem is we're not handling the dot dot, which we would actually like to do up here. Because the troubling case is if we have a directory that is only files, then oh no, that's okay. If we have, let's see here, we say ls, we get a directory and 3 files. Oh, the directory isn't where we do the recursion. The directory is just where we get the file names from. File names. Or rather, directory names. And then these are going to go somewhere else, like after we do the loop. And then this is going to be directory names, but we do need to push the file contents on also. So I guess we still need let me directory contents. I'm also not doing a good job being consistent with my directories versus my folders. I should just call them all directories, directory contents, directory names dot push name. And then directory contents is going to be what we push on there. And now for each of the directory names, we need to do the recursion is the thing. So for directory, in directory names, we say something like this. So we get the recursion results, we get the, so when we get the recursion results, we're going to be expecting LS's. No, we're going to be expecting CDs. We're going to be expecting CDs. So we ls, we get a bunch of directories. And then we're expecting CDs. So why am I even keeping track of the directory names? Do I even need to? It's not clear that I do. Seems like all I need to do is peek at the next item, and if it's a cd dot dot, I have to pop out of this. Otherwise, I can recurse. So like, while let some command cd directory name is stream.peak. Then if directory name equals dot dot, whoops, then we break. Otherwise, I could just pop this. Either way, I want to have consumed it. Otherwise, we take our recursion results. We recurse in, we get our recursion results, and we take our resulting node, and we push it onto directory contents. All right. Something feels off in here, but let's see how we do. Let's see how we do. So file tree constructs from the command stream. Fails. From command stream called on a non-initial non-ls command. That looks like an ls command. Starts with ls. That's because I no longer want to do this. This is an error message issue. This should now be cd command. So I did want to peek here. peak here, and then here we'll need to consume let dot be stream dot pop. And command stream, we will say pub function peak at self option command self dot commands 0. Does that return an option? No, it does not. So we can say if self.length, if self.commands.length equals 0, return none, and otherwise we return sum 0. And we clone. Okay. Let's see if that's better. Hey. All right. Recursion seems to be working. In which case, let's go ahead and test the actual problem. So it looks like I already set up the test, which is nice. Did I already set up my function? I did not. So my function is going to, I'm pretty sure it just takes a string. So let's get rid of this. And then let stream equal command stream from string input. Let file tree equal file tree node from command stream. And then we want to return file tree sum sizes if, and it's like, what was it in the question? At most 100,000. So if x is less than or equal to 100,000. Okay. And this needs to be mutable. All right. And then the only other problem is that in my test, I am passing in a vector of strings, which we do not want. To single string. And we'll change this also to single string. And now that runs. And we'll go ahead and change these to single string. Not going to use that. Not going to use that. And now the only problem is I didn't change this call site. Okay. And there's one more error somewhere. Stream results. We can go ahead and unwrap this. And it's fine if it panics. All right. Run test. We get a failure because Because one of my files has the wrong line endings, because I'm using Windows for reasons that aren't important. Mostly because my Mac is not fast enough to stream with. Okay, let's try this one more time. Or maybe 7 more times. Hard to know. Hard to know. Okay. So we have hit an issue on ABC, it looks like. So ABCD, so it just immediately hit an issue. Even though, didn't my test just work? Am I crazy? Didn't I use like the same test? I ran the wrong test. My test is still failing. Lols. Okay, still failing. Cool. So we come in here. Oh, we shouldn't pop this. We should peek this. Let's use cargo test problem 7. Okay, and now we're getting proper answers. File tree construction from command stream is still failing now. 5 is not equal to 6. So, do I believe that I did this right? 1, 2, 3, 4, 5, 6. Feels like the answer should be 6. Let's find out what the tree looks like. Input tree variables optimized away. Okay, directory, that makes sense. We have 3 things. We should have 4 things. Why do we only have 3 things? We have 2 files and a directory. This is b.txt. Somehow we missed A. And also somehow we got a... Okay, so the files are getting pushed on first, which shouldn't matter. That makes sense to me, but then why are we getting CD here? Or why are we getting the root directory here is the question. So this feels like it should be doing what I want it to be doing, but let's stop. Let's check. That's the wrong one. This does not matter to me. This, wait, shouldn't it have already hit the thing? Why is that grayed out? Confused. Parses from command stream. Okay, here we go. So it's not a dot dot. We get an ls command. We sure do. We get a directory, and we push that on. We get a couple of files. We get another directory. This is all good. And so now we're saying we expect to be CDing now. Which I believe we do. We're CDing into A. Okay, so now we're inside of A. And we get a file inside of A. And nothing else. And so we return our one thing that was in there. As a directory with one set of contents. That seems right. So we pop back out. But now the while let doesn't go. Why is that? The stream has length 0 all of a sudden. Why does the stream have length 0? Why does the stream have length 0? We CD'd into A. Oh, because we never CD into D. Okay, that should just never happen in reality. So let's go get a couple more line. I guess we'll just say, so we CD'd into A, so then there should be CD dot dot. And then CD D, and this can be empty. Just let this be empty. I guess we have to have a deer. No, we don't. We have to have an ls here, I guess. Okay, and so this was just a wrong assumption. In our calculation of depth, it can absolutely be the case that a directory is empty. So in this case, we just want to OR to 0. Or to 1. If you just had the, we want to OR to 1. I want to give an option T back. I want to give a T back. So I guess I have to use unwrap or else. Doesn't really seem right. Get or insert, map or, okay, or. Okay, let's just wrap. Oh, here we go. Unwrap or. 1. Cargo test problem 7. Okay, there we go. Now we're passing. Sweet. And now let's check out what our failure was on 7A, which the error message of which should have our answer. Whoops, except it's not getting the right answer. For the example. Do I believe that my input example has the right length? Maybe. Let's paste it in again just to be sure. It did have the right length. Same failure. So we're a little bit small. We're a little bit short. Interesting. Let's check what's going on at the end of the file. So at the end of the file, we ls into something that has 4 files. Let's add some assertions. How big do we think this should be? So 1, 2, 3, 4, 5, 6. I guess we can just count the letters. So K is the what? H is 8, so K is 11. So it should have a depth. It should have a size of 11. Answer is a number though. Alright, let's add it to our test here. I suppose. Yank this. Let input equal this, and we'll need to make these all strings. That's satisfying. Okay, and this is a back, and okay. And then these are the same, but this we said should be 11, and the depth is probably like 4 or something. And the total sizes we can work out if we want to. Let's just run this first. Expect it to fail even on the length. Okay, it has more nodes than it's meant to. Fascinating. Fascinating. How is it ending up with more nodes than it's meant to? Let's just look at the tree. Hold for one moment. I have to let my cat out. Let's skip this for now. And I would like to look at the tree. Okay, the tree is a directory with 4 children, A, B, C, and D, presumably. 2 files, 2 directories. Cool. The files can't have any children. Directory, and then we get a slash. So that's wrong. How are we getting a slash here? Pop does what I think it does, right? Removes the first element, yeah, okay. So let's look at this. Oh, this is going to be slightly annoying. Let's comment this out for the moment. Probably should put these in separate tests, but what are you going to do? Whoop. Click the button twice, probably don't want to do that. Okay, so this is the first time it gets called. So the thing I'm wondering about is what's going on here. Why did it keep jumping me back here? Debug. Skip. It's not getting run anywhere in here. There's no recursion. The recursion doesn't happen until here. Okay. And so here the recursion happens. And stream starts with CDA. Sure does. Okay, so now we should be inside of that, which we are. What is file name? Oh, I bet, file name is the wrong thing. Is file name ever getting used? Might not be necessary anymore. File name this should be directory name. What even is folder name? Folder name is the directory that we're in currently. Which is what we want at the end of this. Folder name. And then I think we don't need file name at all. Oh, we do. No, we just peek. We don't. Okay. And let's give this a better name. Let's call it outer directory name. And then we can call this inner directory name. But it's not even necessary. Okay, simplifying things. Which is good. Test still fails. Okay, debug. Okay, so now we expect to be in A. If we look at stream, oh, I went one too far forward. So if we look at next command, it's a CD command with A, which is good. So let's go to the end of this. And we should have popped off the one thing. Is there an inner directory name here? E, okay. So sure, so now we're in E. And the stream is just supposed to get ... So outer directory name, we pop off the ls. We should have one file, which we do. There should be one thing. It's a ... So we should pop, which we do. And now we're back at E, popping out of E, popping out of E. Now we're back at A. And the stream now is another CD dot dot. We're still at A, we get a CD dot dot, we pop. Whoa, how did we get back to having 8? Oh. Right, we update the stream. Good. Now we're going to CD into D and LS it. So now we're in D. D has some files in it. J and so on. Stream now has 0. And the directory contents is 2 files and a directory. 2 files and 2 directories. Okay, so that all seems correct. And now if I look at my tree, it's a directory with 4 children, 2 files. It has a directory A, which also has 4 children. Oh, I counted the leaf nodes. I shouldn't have just counted the leaf nodes. Okay, but this feels like it's working right, so that's exciting. So it's 11 leaf nodes, but then it's also a slash. That would be 12. Still not the right number. So there's slash. This isn't the right number, right? It was 14. Yeah, I think it's 14. Ah, because then there's dlog and d extension. But there's only one h list. Okay. Okay. So 14, we think that the depth is 4. Because there's slash, there's A. A and D are siblings. A has E within it. E has I within it. So that would be 4. And if you go into D, it's only 3. So we think this is 4. And then these are some complex sum of things that I'd rather not add up. I feel like doing that. Okay, that passes now. So this whole test should pass. The problem is I haven't fixed anything about this. Still a little bit off. And did I type the number in right? Let's just double check. Solve problem 07A. Aha. Okay. The problem is I'm not I'm meant to double count certain directories. Got it. That's my issue. Okay. That was in the instructions, but I forgot about it. Cool. So let's just call that sum sizes, and let's say pub function redundant sum sizes if self function usize to bool usize and it's basically gonna be this, except if it's a directory, then I need to also calculate the size of the directory. So we'll say self sum directory. I mean, really, this is just children.iter.sum plus that. And I want this to be a usize. Yeah, I guess this isn't what that is it? I can just say sum sizes though. Right. So directory size. And we say let directory size be self.sum sizes. And we probably need to say conditional directory size is if f of directory size, then directory size otherwise 0, and this becomes conditional directory size. This needs to be a usize. Okay. And I'm not even gonna do the other one. And then we'll just say redundant sum sizes if. All right. And still off. 9443 is the same thing, right? That's what it was before. Yeah, 9443. The directory size is just the sum the conditional directory size is 0. And then we add that to the sum. You can count files more than once because it counts the directory. Oh. Oh, this is actually weird. We're no longer redundantly counting when we go through the files. But if I make this redundant, then okay, I get the issue. That's the current directory size. That's the conditional directory size. If the directory size is big enough, then you want to add it. If it's not, then you don't. No, this is fine. So I should just be able to say redundant here. Okay, cool. No, not cool. Not cool. Conditional directory sizes. The total size of the contents. And now we'll say, let children results be this. So then surely this is just the conditional directory size plus the children results. But it's not for some reason, it's double counting. E should be counted as a single file, but it also should be counted in with A. So the conditional directory size should be the size of A. And the children result should be E. Should be the size of E. And the redundancy shouldn't matter. Hey, Nathaniel Bumpo. Yeah, the problem states the sizes of all the sample outputs. Maybe you should make sure all those are correct. Yeah. I'm pretty convinced that this function is just not quite doing what I need it to do. But I'm surprised I don't just see it. Let's just drill into it from here. And see what's going on. Okay. So this is the outermost directory. Outermost directory is huge. Conditional should be 0. It's optimized away. Fine. This is a directory. Okay, this is 0. Children result. Children result is going to depend on what's going on inside it. So now we're at why is this bigger? Am I crazy? Seems like it's bigger than the last number. I guess not. File, so we're on b.txt. So we return, and now we're on C. Let's just keep going. I want to get to something relatively small. Okay, 9443 is the sum of this directory. So this one should get added. So So the condition should pass. So it's optimized away. It is a directory. Conditional directory size is correct. Now we're inside F. F is small enough that it should return. It does return. We're inside G. G is small enough that it should return. We're inside H. E. I. Conditional directory size here is still, yeah, never gets used. What I would expect. D. D is enormous. And the directory, the size of the directory is the sum of all of its contents, right? Yes. That is what it is. Okay, we're on K. K is the last one. So here we're in D. The directory is too big. Do I believe that? Directory D has a total size of that. Yes, that is accurate. And its children result is 0. So this one worked. Now we're in the top level file. Its children result is way too big. Its size is 0. So what happened there? Okay, we're in, okay, so this is being in E. Yes. Yes, it has length 1. Its size is going to be wrong. Why is its conditional directory size getting double counted? We're in E. E should only get counted all the directory. That's my issue. The puzzle says all directories with a total size. Not directories plus files. So let's change the name of this to redundant sum directory size is if, and then that doesn't quite work, does it? So I guess one thing I could do is just subtract all of the file sizes off at the end. Which is just the same thing as sum sizes. Because they're all going to get counted exactly once. So this can just be pub redundant sum directory sizes. And this is just self-redundant sum sizes if f minus self.sum sizes. Okay. And this needs to be some directory sizes. What did I call it? I misspelled it. Okay. Let's try again. And that doesn't work either. Yeah. It's sum sizes if that I need to subtract off, right? There we go. Finally. Okay. Cool. We see a result, 1667,443. Let's take a look. Boom. All right, that was a slog. All right, I gotta go in a minute. Let's just see how easy this one is. Now you're ready to choose a directory to delete. The total disk space available up to the file system is 70 million. To run the update, you need unused space of at least 30 million. You need to find a directory that you can delete that will free up enough space to run the update. In the example above, blah, blah, blah. In the example above, the total size of the outermost directory and thus the total amount of used space is that. This means that the size of the unused space must currently be that, which isn't quite the 300 or the 30 million you need. Therefore, the update still requires a directory with the total size of at least 8 million to delete. You have the following options. You can delete those directories. Deleting those two are too small. Deleting them wouldn't free up enough space. But you have two directories that are big enough, so we want to choose the minimum directory that deleting that one directory would free up enough space. Okay. So we're just going to walk our tree and say, we're going to figure out how much space we need. We're going to walk our tree, and we're going to find the one that's closest to that tree. Okay, let's just do this really quickly, because it should be doable. Just give me one. Just give me 1 second. Okay. Cool. Let's just bang this out quickly. So we need a test. Same one as this one, basically. Except it should be B, and the answer should be the total size of D, which is this number. Okay. And then we're going to need to compute the amount of total space we need to free up, which I think we can just manually do. So let total size be, I guess we have to parse the string first, huh? Let mute string be command from string, put unwrap. I guess I could just take the same thing, and then total size is file tree dot sum. Let needed size be 770 million minus total size. And then we want to get file tree dot smallest directory such that x is less than, or x is greater than or equal to needed size is what we want. And for that, we can say a function smallest directory such that self f function usize bool usize, and we say match self if it's a file, then we'll return infinity. If f of size, then we return size. Otherwise, we return usize max. then we say directory size is self dot some sizes, let smallest child size be children dot iter dot map c dot smallest directory such that dot min I guess we can dot or unwrap or usize max, and then if directory size is greater than or equal to smallest child size, or is less than or equal to smaller child size, we will return it. Size else smallest child size. Okay. Needed to be dereferenced. Needs to be dereferenced. And misspelled children. And this needs a return. Okay. Unwrap or, and this can just be this. Okay. And smallest such that greater than needed size. This gives us back a U size. Am I not allowed to use needed size in here? Interesting. So I guess this was a constant, and this isn't a constant. Can I do it this way? I cannot. It's the same story. Can I say X limit? And then say size. Yeah, that really doesn't work. Sure. I get why that doesn't work. Okay, I get why a closure wouldn't be coercible into a function. If it captures variables, that makes sense to me. Let's just change this and say smallest directory smaller than, bigger than, and we'll say needed size, and this will not be a function any longer. This will instead just be a usize. And this will be limit, and this will be well, I guess it's cleaner to just say if size is greater than or equal to limit, then size, blah, 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 and same thing here. And same thing here. We need if directory size is greater than or equal to limit and directory size is smaller. And we get an answer. Oh, by the way, we never put in our answer here. 1667443. And whoops, that was the wrong one. And this one is 303.24496. Everything passes. Let's check our answer. Interesting that the sample answer is bigger than the actual answer, but can you see this? You cannot. And go. Not the right answer. Our answer is too high. But we're satisfying the sample answer. Which is very interesting. So 70 million is probably correct. Smallest directory bigger than. So we say if our thing is bigger than the limit, we return it, otherwise we return max. We get the smallest child size. I definitely pasted in the right number. Let's just double check. Uh, 3032449 Hey USMT PSilic, thanks for the follow. How you doing today? Smallest directory bigger than. Smallest child size. Unwrap or. The directory size is bigger than the limit. And the directory size is smaller than we return. Yeah, so this is just taking the max. Well, is this just what usize max equals? Out of curiosity. Request usize max. Nope, it's way bigger. Way bigger. Okay. So it's getting an answer. So the current directory size. And this looks okay to me. Let's do this a little bit better. Comment this out for a moment. Don't care about that. I'm running the wrong test, aren't I? Sure am. Alright, I'm gonna have to run in a moment if I can't work this one out. Okay, so the directory is huge. limit is that? Still limit, right? $70 million. Oh, I need unused. The limit's not right. Total disk space is, that's the problem. Okay. So total size, needed size is, I need to get below 70. I need unused of at least 30. So why am I ever using okay, so it's total disk space is 70 million. Needed disk space is 30 million. Total size is that. So the needed size is needed disk space minus. So why did I even need the 70 million at all? Total used disk space is 43 million. The unused space is 70 minus that 40. So unused space is 70 million is total disk space minus total size is unused. So then the update still requires needed space be unused disk space minus be needed disk space minus unused. Pretty sure you don't need the, but whatever. Okay. Fails with a number. This number had better be smaller. It is smaller. It is smaller. I've lost my prompt. Here we go. There we go. Okay, cool. Sick. Okay, we're going to stop there. Next time, which will be tomorrow, I will start in on question 8. Should be fun to keep going. Hopefully, this was interesting to folks. I think a couple of things I took away from this were the recursion, I think, was pretty interesting. I'm not sure I've quite seen a recursion problem that looked exactly like this before, where you had the like CD into two different things, and one of them was where you pop out of the recursion. I think it's just a hidden version of a pretty standard problem, but it was a little bit hard to work through. I think the parser, or the lexer, whatever you want to call it, is pretty cool. I think we're going to be able to use this idea again. Hopefully we can generalize, but things like being able to peak and consume and so on and so forth are really powerful. And I have to learn to read the question better because I think both, like, I got stuck on for a moment on this where it was just like, hey, we've given you two numbers and you're using the wrong one, and also the issue where you had to double count certain files I had read about last time and then had forgotten about for this time. So reading the question, always important, always the source of a fair amount of the bugs in these things. But anyway, hope everybody has a good day. Please follow if you haven't yet. It helps me out. And I will catch y'all tomorrow. Have a good one.